Hello, my dear students. Welcome back to my class. In the series of learning data structures through C, in the previous video, we discussed about the node creation code. How to create a node. So, we have seen the code of creating a node. So, in today's video, we will have a fast glance on that node creation code, as well as we will proceed with the first operation of the linked list, which is traversal. So what is this traversal? How to do the traversal in linked list? The algorithm of traversal and this node creation code. All these things we will discuss in detail. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So what is this traversal? The name itself tells you traversal means traveling to every node of the linked list. In the previous video, we have seen this node creation code. That is how a node has to be created. So we will have a fast glance on this node creation. Then we will go to this traversal. Traversal means visiting every node of linked list. Visiting every node of linked list at least once. So we will have a fast glance on this node creation. Then we will get back to this traversal. As you all know, here you can see node. And node is a one which contains two parts. One is data part, the other one is the link part. So I have discussed about this node creation code in the previous video. Please do check out the playlist. Okay. So a node is one which contains two parts. One is data part, the other one is link part, where link is a pointer variable which points to another node of the same type. So how to create such a type of structure? With the help of user defined data type, that is structure. So I create a structure by name node followed with two members. One is of fundamental type, the other one is a pointer variable. It is a pointer variable of the same structure, acting as member. So we have two members. One is of fundamental type. The other one is of this same structure type, which is a pointer variable. Means it is pointing to a location that can hold no type of data. So this is a pointer variable of the same structure. This is called a self-referential structure. A pointer variable of the same structure acting as member. Right. Then we need to create a pointer variable of this structure type. So every time when I create a pointer variable of the structure type, I have to completely write struct node then pointer variable. So what I'll do, I'll type def that struct node to one single word called as node. So I say type def struct node as node. So every time when I create a pointer variable of this node type, I need not say struct, node, all these things. Only one word which is node. That is what type def. Redefining the data type name. So I say node. So when I want to create a pointer variable, I need not say struct node, I say node. I say node followed with a pointer variable, some name, say p. So I have a pointer variable p of node type, means it can point to a location that can store no type of data, means it can store data and a link. So how to create this memory? How to get this memory? I get that memory with the help of the standard library function malloc. So I am doing dynamic memory allocation, allocating the memory dynamically during runtime. So randomly the memory I am going to fetch from the free store. So that memory is obtained with the help of the standard library function malloc. So what the malloc will do, it is going to allocate the memory to store node type of data. So I have to provide some argument saying that malloc allocate the memory of the size of node. Node size of memory I need to allocate. How much memory I need to allocate, that I need to say, right? I need to allocate how much amount of memory, means size of operator will tell you the amount of memory to be allocated. So size of is the special operator. Size of what? Node type. So node type of data means one is data, the other one is link. So that much amount of data I need to store means that much amount of memory I require. So that amount of memory it is obtained with the help of size of operator. So size of node type is allocated. So this is what the free memory say. Let me say the free memory is 300. So this memory has to be typecasted to node pointer, and that memory address has to be stored to this pointer variable which is of node type. So you all know a pointer is a special variable, of course, that can point to the address of another variable, but it should be of the same type. So this pointer variable should also be of the node type to point to the node type of data. So I should point to node type of data means that pointer should be also of node type. So this pointer is getting this address 300. So this pointer is pointing to this location, where in this location I can store node type of data, means one is data, the other one is link, where that link is a pointer variable once again. So it has to link to one more location. Again I need to allocate the memory. It has to point to another location of the same type. This is what self-referential structure. So it is pointing to the same structure once again. So it's a pointer variable pointing to the same structure once again means again data and then link. So this is what I have explained in the previous video. You can just go and check out the playlist. Hope you have understood this node creation code. Now let us assume that we have already created the nodes and a linked list is established. Nodes are created and it is linked to each other. The address of the first node will be held in the start pointer, where that start pointer will also be of node type. So I will say node asterisk start. Then I say start equal to again that node type, this one, node asterisk malloc, the same line, size of node. So I am going to allocate a memory. Say assume this is what the memory that what I have obtained for the first node. So the address of this first node will be held in start. So start will always be pointing to the first node. So look at here, 100. It is pointing to the location 100. So the data part I have written 10. Link part I say 200 means it is the address of the next node. So as I said, it is going to have a pointer variable which is acting as a member pointing to one more location to store node type of data itself once again means once again data and link. So again data and link. This is what I have created. So again data and link. Data is 20. Link is the next node address 300. Data is 30. Link is null means it is not pointing to any other node. So I have three nodes here. With the help of the traversal algorithm, I should see how I can visit every node of the linked list. Right. So start I should not disturb. Start should always point to the first node. But I need to take an extra pointer variable. With the help of that pointer variable, I have to do the traversal. I have to visit every node. So let us see how to visit every node now. So here this is what the algorithm. I say the first step p equal to start. So I have created this pointer variable. I say whatever address you have in start, you store. This is already created linked list and the list of nodes are already being created. You have to assume that. So you have these nodes and need to do the traversal. Traversal means visiting every node of the linked list. So what I'll do, I say p equal to start. P equal to start. So when I say p equal to start, whatever address I have in the start, That will be stored in P. So what do I have in start? I have the address of first node. That I need to copy to P. So now I have a pointer variable P which is having the address of first node, means it is pointing to this location. That is what the meaning. So P is pointing to first node. So I am going to store the address of start in P. Then I say P not equal to null. So P is 100. So let me write the iterations now. 100 not equal to null. Is that true? 100 not equal to null. Yes, it is not equal to null. If this condition is true, execute these two statements. Process the data part of P. P is pointing to 100. Data part of 100 is 10. So process that 10. So I'll do. I think during the process of traversal, I may do many operations. I may search for an element. I may find the location, position of an element. All these things, right? So process means it can be anything. So I take the data, I do something. Then the next line is P equal to link of P. So I just say P equal to whatever I have in the link of P. Link part of P. P is pointing to 100. Link part of 100 is 200. P is 100. Link part of 100 is 200. That you store to P. So now P is 200. So what is the new value of P? It is 200. Now this P is not pointing to 100. It is pointing to 200. So that is why as these changes happens, I am not disturbing start. Start should always point to the first node. So I am taking this temporary pointer. With this temporary pointer, I am doing the traversal. Hope you are understanding this. So P is 200 now. Again, after executing these two statements, loop back, check once again. P not equal to null. Now P is 200. 200 not equal to null. Yes, condition true. Okay, then process the data part of 200. Process the data part of P. Data part of P. P is pointing to 200. Data part of 200 is 20. So process 20. So some operation I will do. Next line, P of equal to link of P. So right now what is P? P is 200. Link part of 200 is 300. Store that to P. Now P is 300. Now P is how much? It is 300. So now P is pointing to 300. Again, go back. 300 not equal to null? Yes, of course, P not equal to null. Yes, it is pointing to 300. It is not pointing to null. Condition true. Then again process data part of P. So P is pointing to 300. Data part of 300 is 30. Process 30. Some operation. Then I say P equal to link of P. P is 300. P is 300. Link part of 300 is null. Store that to P. Now P is not pointing to 300. Now it is null. It is not pointing to any location. Right. Again go back. Now P is how much? P is how much? Null. Null not equal to null. Condition not satisfied. P not equal to null? No, it is equal to null. Condition not satisfied. End of while, then return. So have I traversed the entire linked list? I processed the data part of 100, 10, data part of 200, 20, data part of 300, 30. So when I reach the last node, then the pointer is null. So it is not pointing to any other node. Then I should stop traversing. So this is what the traversal algorithm. Hope you have understood these iterations. You have to write down these iterations and you have to work out by yourself. Then only you can understand. Any doubts if you have related to these iterations, you can ask me in the comment box. So this is what the traversal algorithm and the node creation code. Hope you have understood all these things. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.